Welcome back to another episode of DF Retro Extra, where we explore interesting projects and ideas exhibiting that retro spirit. There will be more regular episodes of the show coming up, but today we have two special guests with us to discuss Ion Maiden, a new shooter being developed with old technology, namely the build engine. For those unfamiliar with the build engine, this is the technology that powered games like Duke Nukem 3D, Shadow Warrior, Blood, and the PC version of Power Slave. Retro-style games have become common these days, but few are developed with actual vintage technology. The idea today then is to hopefully shine a light on the process of creating a brand new game with a rather old engine. To discuss the game then, I'm joined by Frederik Schreiber, the Vice President of 3D Realms, and Evan Ramos, co-founder of Voidpoint, who's developing the game. But before we dive into the technical side of things, I have to know, what is it that drove you to go back and work with old technology in the first place?
So the main reason was, I think we have to go back almost 3 years from now, and we were working on this idea at 3D Realms of making kind of a throwback game. But the original idea was, what if we went to the old 3D Realms archives and we found this secret game they worked on in the mid-90s, and it would be a successor to the build engine line of games, but it was too awesome to release, so they just kept it there as this, treasured object. And partly also because we have a big fascination. We often talk about redoing or doing brand new games in older engines or for older platforms. We have a big fascination with that, especially when you're limited within, certain tag limits or scope limits,
right?
Which is really fascinating. So we wrote up this small concept on, a prequel to Bombshell, which would take place in 1996. So it would basically be, what if you had Shadow Warrior, you had Duke Nukem 3D, and you had Bombshell, and then those three franchises then 10, 20 years later turned into big franchises with multiple games. So we kind of went back to that. And then I started looking for people, and the obvious first place to look would be the Duke 4net and build engine communities, where I've known Evan and Richard for a while there, since we took over 3D Realms, but those were the obvious first people I got in touch with. So I reached out to Evan and reached out to Richard and asked them, hey, would you guys like to work with us on a little official build engine game from 3D Realms? And to my luck, they said yes.
Wow, that's amazing. So now I think I've read that this is based on the eDuke 32 line.
Mm-hmm. Yep, that's correct.
So can you talk a little bit about the actual tools that you're using to make this game? I mean, I assume you've maybe made new tools to work in in modern engine, or is this still like the classic build tools?
Well, the primary tool that's used, the map editor, is in fact descended from the original build editor that was released with the original games. So we work on a project called eDuke 32. For those not familiar, eDuke 32 is a source port, meaning that the source code to a game was released sometime in the past, and now fans have taken that and continued to work on it over time, usually under permissive licenses that permit for this kind of thing. So, along with the game Duke Nukem 3D, which we've helped bring into the modern era with things like widescreen support and increased resolutions, better performance, more mod tools, more modding capabilities, especially in the scripting, we've also brought the build editor into the 21st century, and we call that Mapster 32, and a pun on the old service Napster. I guess we've outlived that name by a bit. So yeah, the map editor is still what the original team used, but a lot of the other things are more modern tools. For example, our artist still uses Photoshop and drawing tablets, that kind of thing. He calls it low-resolution digital painting, actually. And of course, text editors and everything are using modern development environments like Visual Studio and so on. But I'd say the primary gem of what we're using is the level editor, which is the same as it always has been.
Okay, that's cool. So when you're authoring assets and textures and whatnot, what kind of limitations are there with the current iteration of build?
So in the style that we've gone for, which is a bit of a 1996 throwback, that will also run in the same software renderer that it used to, the first thing that comes to mind would be the 8-bit or 256 color palette that we're limited to.
Mm-hmm.
But it more than just a limitation, it's also more like what a classical painter, like the term palette literally comes from having a board with paint on it, and you have certain colors to choose from. And we only have 250 or so that we can really use. So it's up to our artists to determine what's a coherent style to use with these colors and so on. And of course, the next limit is the size of the assets themselves.
Exactly.
So, like our textures and our sprites. Right after the original Build engine games came out, the most successful first ones of them, Duke Nukem 3D, Blood, Shadow Warrior, Redneck Rampage, right after those, Quake hit. And Quake changed the face of gaming by introducing dynamic lighting and 3D polygonal objects, or 3D models as we call them. Whereas up to that point, in the Build games, in the Doom engine games, you had flat images that were billboarded around the game world, and these were usually photo-sourced, or sometimes they were drawn as well. But your game world was populated by boxy geometry thanks to the engine, and these flat images everywhere that we call sprites.
Of course.
So, with the 2D engine, a sprite would be like in screen space, but in our game world, sprites can be out, and there's distance and perspective and all of these things that are calculated.
And what kind of size differences are here in terms of like resolution of the sprites per se, like versus Duke Nukem 3D to Ion Maiden? Like, what kind of jump are we looking at here? Because they do appear a lot higher resolution.
They are. So Doom had a certain size of its sprites. I don't remember the numbers offhand. I'm not going to for any of these, but after Doom there was Duke, and that had slightly bigger sprites. I say between a factor of about maybe 1.5 to 2. And then there was Shadow Warrior, which increased that a little bit more, and in the end I think Redneck Rampage started drawing the screen sprites instead of targeting 320 by 200, for example, like the weapons and the status bar, that kind of thing. Instead, they're targeting 640 by 480, and that's where we decided to pick up the slack. So we have all our weapons in double the resolution of what Duke Nukem and Shadow Warrior and Blood used, and our game world sprites are actually some of the largest that have ever been in a Build game or a 2D shooter. I think our limit is something around 256 by 256. Like, that's the engine limit. And so we are, I don't think we've completely maxed out that ratio because you do want to leave some headroom, but we're using the most of those pixels as we can.
That's great. Another thing I noticed is the use. It seems like with the decades of knowledge of modern rendering, I've noticed a lot of artistic flourishes that sort of simulate more realistic things, like long shadows. They're not real shadows, obviously. You're just using the engine to do it, but there's like this, the lighting and the colors. Can you talk a little bit about the process and like what you guys went through in terms of like pushing the Build engine with these sort of new techniques?
Certainly. So the original software renderer that we call Classic, very affectionately, is worked only in those 256 colors. And the key of that was that instead of using math with something like red, green, blue, the components and doing actual color blending and so on, instead, the Build engine relied very heavily on what are called lookup tables.
Oh yes,
and
of course.
There were roughly 3 different types that I can talk about. The first would be simple shade tables. So if you ever pull up the palette of an old Doom or Build game and look at it, like in Photoshop or something, you'll see that it has some different hues of colors, and then they fade to black. So those are generally the colors we have to work with. And a shade table will take any of those 256 colors that may be present in our art assets and gradually remap them on this table to get darker. So that's the shade table. The next one would be called lookups or pal swaps. So, for example, in the original Duke Nukem 3D, you had the most common enemy was called the Assault Trooper, but there was a variant of that enemy called the Assault Captain, and they used the same art assets, but the uniform was colored blue in the actual image, and for one of those variants it was remapped using a PAL swap or a PAL lookup to be green, and for the other it was remapped to be orange. This concept has been used in various things, like if you play multiplayer in any of the build games, usually the player character will have some kind of image or feature on their costume. So like the Duke has the blue jeans, Doom Guy has the green suit, and those would be remapped to other colors. So it's basically getting more use out of the same assets. And finally, the third type is, before I go into that, one key point on the lookups is that, so Duke Nukem 3D had roughly 25 of them, Shadow Warrior had roughly 30, we are over 120, pushing 150, I believe.
Wow.
And that's out of 256 slots that are available to us. So we have far more color variations available, both for enemies and for textures in the game world than any of the previous games have done. And the third type of lookup table that the engine uses is called a blend table, and that's a bit of a neologism because originally the build engine didn't have any ability to use more than one of these at a time, and all of the existing original games used this for 33% or 66% alpha transparency. So something very simple, just like you pulled an image into Photoshop and turned the alpha slider or the transparency slider one way or another.
Right.
It's a very uninteresting form of blending, but it does provide some effects like translucency for smoke and that kind of thing.
Oh yeah, wow, that's cool.
One of the features that we added to eDuke 32 as part of the development for modding capabilities was the ability to swap out this blend table to do other things. And we use this to extensive effect in our game. So one example would be additive blending. And additive blending means that so you take two colors, and when you combine them, it's like the intensity of the color gets added together, and in physics, this type of color blending is used for light. So what this allows us to do is take a texture, some kind of image, and blend it with the scenery using alpha blending, which can be used to fake light sources, kind of like any of the old Quake Engine games that bake light maps.
Oh, right, yeah, of course.
So we're kind of doing that in a manual fashion. Like we have a small toolkit of different lighting sprites that we can use from, and the mappers can activate a blend mode and make it appear as if there's really light shining.
Yeah, I think some of the stuff in the beginning, like those transparent pieces of glass, like they sort of cast like a fake light on the floor. That looks quite cool.
So it's like there's a copy of the image on the screen, and then there's another copy of it on the floor that's set to blend in some way.
One other feature that I'm not sure if it makes sense for Ion Maiden or not is the Polymer renderer that Ken Silverman did, or perhaps the more advanced Polymer, which you guys added to eDuke 32.
Yes.
Did you ever consider using the Polymer features for Ion Maiden?
So Polymost and Polymer are two separate renderers. That's what we call a back end for drawing things, and I'll have to explain a little bit of history of these two projects. So originally, in the year 2000, Ken Silverman released the source code to the build engine. That was not attached to any games, so you couldn't do a lot with it, but it did include a very basic editor and the tech demo that he used to present the game to various companies in the heyday of the engine. In the year 2003, 3D Realms released the source code to Duke Nukem 3D. So when that happened, then in earnest people could start hacking on the code to port it to new platforms and add new features and so on. And as this happened, Ken Silverman, the person who wrote the build engine originally, was hoping someone would step up and try writing a version of the build engine renderer that would work using hardware like accelerated graphics. And a few years passed, or a year passed or so, and this didn't happen, so Ken said, you know what, I'm going to do it myself. And he did. He wrote in OpenGL a hardware-accelerated version of the build renderer that made the geometry all show up correctly, and that made its way into a source port known as JF Duke 3D by the eDuke 32 team's close associate, Jonathan Fowler of Australia. And this was the basis for a project many people may know called the Duke Nukem 3D High Resolution Pack. So in addition to being hardware accelerated, the engine also allowed you to define high resolution textures and models as sort of a neat thing. Hey, here's what the direction the game industry took with Quake 3D models and textures and so on. Let's add that to build. Fans had a lot of fun developing stuff using these capabilities, and then this naturally blossomed into, over time, the desire for other things, features that the renderers can provide from other modern games. Dynamic lighting is the big one, like surface maps, normal maps, advanced shading techniques, and the original Polymost renderer was not suitable for those techniques, so another developer from eDuke 32, Plagman is his name, he works at Valve now on the SteamOS project, wrote a 3D renderer using all these advanced shading techniques, or supporting them anyway. So the idea behind those was to make, say, a Duke Nukem 3D mod that could look like a modern game. But for Ion Maiden, our goals was to make a game that looked like Duke Nukem 3D did originally. So it didn't make a lot of sense for us to use the advanced Polymer renderer. The renderer also stopped development at the point of correctness before the point of performance optimization, so it would have been very hard to debut that on a commercial scale.
Sense.
However, Ion Maiden does support the Polymost renderer, primarily because at a certain resolution, about 720p, the software classic renderer really chugs. It's not able to keep a consistent frame rate. And also, if you're running it on a mobile platform, the software renderer will eat through battery very quickly. So we made sure to support the Polymost renderer, which allows for the smoothest gameplay experience for players, and we've tweaked it over the years so that the colors and rendering and so on are very accurate to classic as well. So it's purely a performance upgrade in terms of using it.
One of the cool features, though, that was added to Shadow Warrior and Blood that I'm not sure I've seen yet was the voxelized items. So, are there voxels in Ion Maiden, or is this not something that's going to be included in the game?
There currently are not any voxels. We don't have anyone on the team who is experienced in making them. There are some people in the community who have, but it's a very, very low talent pool skill set. Like after build, those really didn't take off, so the kind of experience you might have in 2D drawing or in 3D modeling doesn't really apply to voxels. It's kind of its own thing.
Okay. Another thing I found interesting was the addition of sort of mid-level loading points rather than... is it just that PCs are fast enough that you can just crunch through it? Like when you're going through the air ducts at the beginning, you get a quick now loading prompt that's just like a split second, and then you're to the next section. Almost akin to like a modern streaming engine. Can you talk about the way you implemented this, or what's going on there?
Sure. So the fact that there are various transition points where you autosave is actually something we added after the fact to something else. So the original build engine had a certain limit on the size of the map or the level that you could build, a certain number of sectors and walls and sprites and so on. And eDuke 32 is in a class of source ports known as limit-raising source ports, which allows us to have more of those. But we thought, what if we want to go even bigger? The engine does have a ceiling at a certain point. There are various calculations that assume a certain maximum size of sectors and walls and so on, so we have reached that cap. But what we did do was use a modding functionality that was added to eDuke 32, originally with the intent of being used for something like the hub maps in Hexen.
Oh, right.
But we used this instead to achieve a sort of Half-Life-like flow of levels that can, in some, break the total map limit, while still providing a cohesive experience that we call zones. So the designation of logical level versus physical level, so like the file format versus what the player considers a level, has been broken with Ion Maiden because we're using multiple map files for one logical level, which we're calling a zone.
Okay, that makes sense. And how much have you pushed? So we've talked about obviously raising the ceiling and what the engine can do. How much advantage are you taking of modern hardware then? I noticed the game is a 64-bit EXE. Are you actually using this extra memory, or is this just a byproduct of just a decision there?
It might be so that we could have a simpler go at it of packaging the game, but there is actually performance benefit that a CPU-heavy calculation can get from 64-bit, even if you're not using more memory. And it goes in really deep into computer engineering, like processor architecture terms, that basically you have these, in processors, you have some scratch space to store numbers called registers.
Right, of course.
And 64-bit has double the number of registers that 32-bit does, at least for the x86 processors common for desktop machines. So the modern C compilers make full use of these in order to get the most out of code. So 64-bit 64-bit executables regularly perform better than 32-bit for a CPU-intensive application like us.
So thinking of that then, what's the theoretical lowest limit in terms of PC hardware that this game could run on?
So, of course, the 64-bit architecture itself is the limiting factor as we package it, but we could build a 32-bit executable if we wanted. There's nothing technically stopping us from doing that and distributing it. The limiting factor really depends on whether you choose to use the software renderer we call Classic or the hardware-accelerated OpenGL renderer we call Polymer.
Yeah, I was curious then, if you had, like, say, an older, like a Pentium 4 that had a 3.6 gigahertz clock on a single core. This is not really a multi-threaded engine from what I'm seeing on my PC usage. So how would you say that could run the software build?
I would say that provided you have enough memory, you'll need to do somewhere between 128 to 256 megabytes of memory, which may or may not be a big amount for a Pentium 4, I guess. But if you go lower, then that's going to start being an issue. But if you do use the software renderer, and if you use a period-accurate monitor resolution, something like 800 by 600, then I predict you could have some success running our game with performance. If you choose to use OpenGL, then of course you're bound. There are two factors that come into play. One is your graphics hardware, and one is still your CPU. And because of the way the build engine was written, or it was conceptualized, it's actually not written in a way that's conducive for modern graphics hardware to process. So it's actually fairly CPU bound, and we're doing extensive amounts of engineering in order to offload some of the work needed to do for hardware accelerated rendering to the graphics hardware. So if you're running OpenGL on a Pentium 4, I predict you might have more issues, especially because the cards with the better driver support for OpenGL stopped being produced for AGP slot machines before cards with worse drivers, so I would have to recommend using the software renderer for if you want, in theory, to run on an old computer.
So you say you are then still optimizing the OpenGL, because one question I've had with the current build is that the performance on my PC when running the OpenGL version isn't quite what I'd hope, and that when you look at certain areas of certain maps, the performance drops to a very, very low level, but the actual GPU usage is very, very low as well. Whereas when I run in software mode, I can get much more stable frame rates overall. And it seems to be a lot of issues with, frame persistence, where there's a lot of inconsistencies in the frame times and whatever. Can you talk a little bit about some of the improvements you're working on there to sort of like put our mind at ease for the final product?
Absolutely, I'd be glad to. So the Polymer renderer was written by Ken Silverman around 2004, 2005. And to do that, he wrote it in the very first major version of the OpenGL API. the fixed function pipeline as it's known today.
Oh, yeah.
And this was done, this is version 1.1. So graphics APIs, or the interface that software uses to talk to the graphics hardware, there's like a middleman called the driver. Those drivers, the software and the hardware as well, have evolved quite a lot since Polymer was written in 2004 and 2005. So our renderer had and still has a number of issues that are very difficult to bring into hardware accelerated programming. The first one is because build is not set up in a way that's conducive for our graphics hardware to run on, and that owes to being dynamic. So all the build games have been well known for things like sector vehicles and advanced scenery that blows up, like the building in Duke Nukem Level 2, that kind of thing. It's really hard for graphics hardware to handle that kind of stuff. So I'm not actually my team's graphics engineer, so my experience does stop at a certain point, but one big thing that's important is called batching. So one of the highest overheads between having a GPU and a CPU is when they have to talk to each other, and to do that they have to establish a protocol between each other and stop what they're doing and transmit stuff. And it's good to have as few of those, they're called synchronization points, as possible. And because we're so dynamic, a lot of those happen. So one of our goals is to sort of cache everything that's static, that doesn't move or is unlikely to move, so that we can only send things that are dynamic down the pipeline, which will make various times much faster. Another thing that we're doing, and should be out in a patch very soon, is optimizing the way we load images or textures and send them to the GPU. So both loading from disk into memory, and then transmitting from main memory to the GPU. So this is a task that's very simple to batch up, and it should gain us a lot of performance due to that was formerly lost in the form of all the stuttering that's been experienced. Another thing has to do with various features we've added to make GL more accurate to classic, and the biggest one there is the shade tables. So because the software renderer has these lookup tables where you put an index in and get an index out of various color shades to use, the GL renderer formerly did that with simple math, and it didn't match. If you look at screenshots of, say, JF Duke 3D and Polymer from the late 2000s versus Educ 32, you'll see that in our GL renderer, a lot of the atmosphere of the game due to the shading and various visibility stuff has been re-added to our GL renderer. And to do that while still having the renderer in a state before shaders, we needed to generate many, many extra images on the CPU side and deploy them to the GPU to use. So instead, we're working on shaders that will perform a calculation using a lookup table on the GPU in order to avoid having, say, 30 extra copies of any image in video memory in order to achieve the shading accuracy.
Okay. That does sound good then. I'm very eager to test out the patch then when it hits. Another thing I noticed then is the music. It sounds to me like you're using tracker music. And I'm wondering, I haven't actually looked too closely into how it's generated. If it's actually just a digital, like a wave kind of file, or if it's actually like real tracker music being played in real time, and if so, how that was implemented in the build engine.
Well, it is in fact tracker music. We have some
amazing.
.xm files in our game data.
Excellent.
We're the first build engine game to use tracker music.
That's right.
Previous games either used general MIDI, often tuned to the Roland Sound Canvas series of MIDI hardware, or they used streaming CD audio. So Shadow Warrior and Blood had those, as well as Redneck Rampage. So we're using tracker music, and we owe the support to our tracker music to an open source, freely available library called libxmp Lite. It's released under a extremely permissive license that allowed us to simply incorporate it into our audio library and have access to playing a variety of tracker formats. In terms of making the music, we actually have a guy from the Finnish demo scene who's familiar with various Amiga hardware and so on, actually composing the music for us.
Oh,
so we have someone with intimate knowledge of the domain of tracker music and adding it to the build engine, which hasn't been seen before.
Yeah, wow, that's really cool. That's quite a nice touch indeed. So knowing then what we've learned about this implementation of build, what do you think it would take to get this up and running on, say, a console, especially with their very limited CPU capabilities?
I think we're a lot of the way there already, because before Ion Maiden, my Voidpoint co-founder Richard and I were working on a port of Duke Nukem 3D to Android and iOS. This project unfortunately did not see the light of day, but we did perform a lot of optimizations to the engine that allowed us to get better performance without the cost of any accuracy. So we have trained our code to the extent of our abilities to run on, say, like an ARM processor and running on something with battery life that we have to conserve and with limited amounts of storage space and so on. So we have a lot of that support already, and that a lot of those things are usually what go in the path from PC to console, like reducing the ceiling of the specifications or the system requirements that we need. So in terms of technology, we are a lot of the way there. We are still doing work on our hardware accelerated engine in order to make it more optimal, like get consistent 60 frames per second even in the most challenging environments. And we're a lot of the way there. In terms of technology, I would say there's nothing really stopping us given enough time to develop our stuff.
Okay, that'd be great. Then I guess this one's more for Fred, actually. If there's any possibility to see perhaps a physical release of Ion Maiden, because as a game collector, I would love to see like a limited build of the game released. You know, Limited Run Games does this, other companies are doing this. What are the possibilities of seeing something like this come to fruition?
Well, I already think we kind of teased this and spilled the beans as we made the decision internally. But for our last game, we tried to set up a proper pipeline to develop full physical box copies. We wanted to get something done for our last game, Red Rogers, and we couldn't find a supplier that could deliver the quality we wanted.
Right.
There are a few different options like limited run and so on, but we wanted to make our own custom press for big box copies, so we could make them just like they were back in the old days with proper, matte and gloss finish and embossing and all these things. So we developed our own complete pipeline for it with a few different partners that are just local companies for pressing cardboard and so on, and we came up with this fantastic result for the Red Rogers box. So we're going to do a version as well for Ion Maiden, a fully boxed copy, and it's going to include a ton of crazy awesome things. One of them is going to be a custom floppy disk that if you slide the little metal slider, a little USB tip comes out of the side. So it's actual floppy disks. It's not reproduction floppy disks. It's actual old floppy disks with the insides taken out and then replaced by this little mechanic. So it looks like a normal floppy, and then once you slide the metal piece, a little USB comes out. So it'll be delivered on those, and then there'll be some other great goodies that we haven't announced yet, but we will talk more about that when we get closer to release. The big box copy of the game will be available exclusively on the Three Realms website, just like in the old days, and it will be shipped worldwide and only made in a limited amount of copies. So that's gonna be super exciting.
Yeah, that's great. I love that kind of stuff. So with what looks to be a very successful revival of the build engine, I'm curious then, because there are other engines sort of sitting way in the background that are kind of incomplete. Would there ever be any sort of ambition in like going back to say like the old unfinished Prey engine, trying to do something with that, knowing that nobody's really probably touched that since the 90s, but that would be that would be an interesting thing.
It would be fantastic. I think so. So back then, right after build, obviously Duke Forever was developed first actually on the build for a very early prototype, and then later on the Quake 1 engine, and then Quake 2, and then Unreal, and so on. But yeah, during the development, all the way back, actually starting in '95. Tom Hall started working on the first iteration of Prey, which was also on the build to start with. But the internal ambition at 3D Realms was to develop an internal engine that could compete with id Tech and Unreal Engine. And that became the Prey engine. And there are some famous footage from the engine, mostly the Infinite Megahertz 97 and 98 interviews, where Paul Shitoma was showcasing different aspects of the engine that were later almost blatantly copied by others. But one example is the portal technology, where they show how portals work with this awesome little blue and orange portal where the character would shoot himself through it. Fully destructible environments as well, real-time lighting, colored lighting, real-time shadows, and so on. So the Prey engine was pretty fantastic. We have the old builds here, and we loved playing around with them, and they are absolutely stunning to look at, especially with the time frame in mind. This was very, very early stuff, and it was just mind-blowing to see how detailed everything was. Unfortunately, we don't know the legals of it. We don't know if Bethesda indeed owns the old engine stuff. They own everything related to the Prey IP, but it's something we have to dig into. We did approach Bethesda just publicly on Twitter asking if we could release any of this stuff, with no response, unfortunately. But so I think the chances of seeing an old Prey engine game with using that engine are very slim, even though it would be insanely cool. We do have, after we started working on Ion Maiden and kind of are going down this path, we are going to do other games using older engines. When we took over 3D Realms, we spent a few years trying to figure out exactly what our path should be and what was most important to us, especially me as a hardcore 3D Realms fan. Like when I was 8 years old, Joe Siegler from 3D Realms sent me a Duke Forever promo DVD because I was so active on the 3D Realms forums, and this is decades ago. So ever since then I've been such a big fan. So my primary goal here was to figure out what is the essence of 3D Realms, instead of bringing back an ancient company and trying to just compete as a publisher and developer. How do we find the essence of what made 3D Realms so great? And for us, that was the time period, between Stargunner, which was the last Apogee branded game, and then until Shadow Warrior. And in that time frame, you had them actually working on. They started development on Blood originally, Ruins, which became Exhumed, and then of course Duke 3D and Shadow Warrior. So we wanted to go back to that mind frame and that era of development, and try and explore that some more. And Ion Maiden was the logical first step, and we were extremely lucky to find so many talented people, and Richard and Evan here, and the guys that they've put together from the build engine community, and then alongside some of our developers who help out with art and level design, it's just turned into this fantastic product. So we do have others coming, in the same spirit and era. I think where we want to differentiate our retro games is, and I think a lot of the different previews that has come out recently has perfectly covered that, is that we're not trying to make retro games or old school games. We're trying to make really good first-person shooters, but using old school technology, which is purely an artistic choice. But it's also, the artistic choice also gives the game a very specific feeling and atmosphere that you just can't replicate nowadays. So we want that feeling and atmosphere in our games, combined with all the knowledge we have now, 20 years later. in terms of game design and game development and so on. So that's definitely a path that will continue down towards at 3D Realms.
That's an interesting approach indeed. It's it's difficult to feel completely authentic when you're building a pixel art game in Unity, but going back to Build, it definitely does feel like a product from that era. Maybe we'll see a new terminal velocity.
That would be pretty kick-ass. Like, we're definitely missing, terminal velocity or descent type of 360-degree shooters nowadays. So that could be something really interesting to go down. Yeah,
for sure. Well, I think that's probably covers everything I have on the agenda for today. But I appreciate you guys coming out and answering all of my crazy questions about the game, and it's looking awesome.
Anytime, John.
I think that's going to wrap it up for this special episode of DF Retro Extra. Thanks for making it all the way to the end, and thanks to Evan and Frederik for joining me on this lovely day.
Thank you.
Thank you so much.
All right, well, that's if you enjoyed this video, be sure to like and subscribe as always, and until next time, stay retro.